Alright, so our next game is our fair dice or our Ludo game. And I believe you all know what a fair dice or a Ludo game is. Now, our fair dice contains, each cube contains 6 faces. Our fair dice, each cube contains 6 faces. And the 6 faces they contain numbers. So we have, for our fair dice, it is 6 faces. Our fair dice contains 6 faces, which are 1, 2, 3, 4, 5, 6. So each face is represented using a figure. Each face is represented using what? A figure. Now, under fair dice, we have that the probability of any of the faces occurring is equal to, now have probability of any face is equal to 1 all over 6. And I believe you all know how this 1 over 6 came to be. Remember, each face is represented by a number and no number was repeated. It is 1, 2, 3, 4, 5, 6. So the probability of having a 1 is, remember our formula for probability, number of events all over our sample space. Okay? Now, for a single fair dice, every event occurred once. So 1 occurred once, 2 occurred once, 3 occurred once, 4 occurred once, 5 occurred once, and 6 occurred once. Therefore, these are events. So we have 6 events, right? And our total number of possible events is 6. So that is how the probability of any phase occurring is 1 all over 6. So the probability of having a 1 is 1 all over 6. Probability of having a 2 is 1 all over 6. Probability of having a 3 is 1 all over 6. Probability of having a 4 is 1 over 6. Probability of having a 5 is 1 over 6. And probability of having a 6 is 1 over 6. Alright, now but just like what we discussed under our coin game, under your fair dice or under your Ludo, now there are some scenarios whereby two Ludo dice or 2 fair dice can be tossed simultaneously, or situations whereby you can have a fair dice being tossed 2 times. Now, in scenarios or in situations like this, how do you solve such questions? In scenarios or in situations like this, how do you solve such questions? Now, there is what we refer to as our dice table. There is what we refer to as our dice table. So whenever you have questions whereby you have a fair dice being tossed twice, or where you have two dice being tossed simultaneously, you just make reference to your dice table. So what does a dice table look like? Alright, this is what our dice table looks like. Now, but basically this dice table is used in situations or in questions that contains just 2 rolling of a fair dice. Okay, or where you have 2 fair dice being rolled simultaneously. Now, this dice table contains the possible occurrences or the possible events when 2 dice are being rolled simultaneously, or whenever you have a fair dice being rolled 2 times. So here we have 1, 1. Here we have 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Here we have 2. Here we have 2, 1. Here we have 2, 2. Here we have 2, 3. Here we have Here we have 6, 4. Here we have 6, 5. Here we have 6, 6. Alright. Now what does these values represent? Now these values actually represent the possible faces that can occur. The possible faces that can occur. So with this table you can basically answer any question under your fair dice that involves a fair dice being tossed twice, or 2 fair dice being tossed simultaneously. Now in this scenario, what is our total number of possible outcomes? we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So whenever you have a feather is being rolled twice, or whenever you have two feathers being rolled simultaneously, our sample space, our total number of possible occurrences is always 36. Our sample space, our total number of possible occurrences is always 36. So from this you can solve any question. Now you can be asked to find probability of having two faces containing one. Here it is just one. So this is it. This is where you have our first face as one and our second face as one. Remember just like remember what I said initially. These digits represents the possible occurrences on each face. This digit represents the possible occurrences on each face. So here we have 1 occurring. Here we have phase 1, phase 2. Here we have phase 1, phase 3, and so on and so forth. So with this, you can basically solve any question under fair dice. So let's look at 1 or 2 questions under this category. Alright, let's look at this example. Now it says 2 dice are thrown at the same time. Find the probability of getting A, at least 1 5, B, a total score divisible by 5. Now I want us to first of all try to always understand our question. Okay. Now remember, whenever a dice is being involved, what you can get is always a face. Okay. So when they say find probability of getting at least 1 5, now this simply means that you should find probability of getting 5 as one of the faces. Remember, the face of a dice, it can be either 1 or 2 or 3 or 4 or 5 or 6. Okay? So this is find probability of getting at least 1 face as 5. Alright? So the total says find a total score divisible by 5. Now this simply means that you should find the probability of getting a face of which, if you sum them together, the value they give you will be divisible by 5. So let's get to the first, the A part of the question. It says at least 5. So we are looking for scenarios whereby we have at least one of the faces to be 1. Now remember what I told us. Now, so this is 2 dice, okay? So we'll be needing this our dice table. Remember what I told us about dice table. Whenever I have a question that involves 2 dice being thrown simultaneously, or a dice being thrown 2 times separately, your best solution, in fact, your solution will always come from what? From your table. Okay, so we need this table to solve this question. At least 5. So we'll start looking for the faces whereby 5 occurred once or twice. Remember here, the occurrences on our faces is 1 and 1. Here we have 1 and 2. Here we have 1 and 3. Here we have 1 and 4, and so on and so forth. So we start looking for where we can find 5. Here we have 1 and 5. So this is 1. Here we have 2 and 5. This is another place. Here we have 3 and 5. This is another place. Here we have 4 and 5. This is another place. Here we have 5 and 5. This is another place. Here we have 5 and 4. Here we have 5 and 3. Here we have 5 and 2. Here we have 5 and 1. We have 5 and 6. Here we have 6 and 5. Okay? So these are the faces whereby 5 occurred either once or twice. And how many are they? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5 occurred once or twice, 11 times. And remember our formula for probability. Now the probability of any event is the number of that event all over our sample space. So the number of 5 at least once is 11 all over. And remember what we said. As long as it involves 2 dice, your sample space is always 36. It will always be 36. So the probability of having at least 1 face as 5 is 11 all over 36. Now let's look at our second part of the question. It says a total score divisible by 5. A total score divisible by 5. So here, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4. 1 plus 4 is 5. Is 5 divisible by 5? Yes. So this is one of the places we are looking out for. 1 5 is 6. 1 6 is 7. 6 2 is 8. 5 2 is 7. 4 2 is 6. 2 3 is 5. Yes, we're looking for this. 2 2 is 4. 2 1 is 3. Now 3 1 is 4. 3 2 is 5. We're looking for this. 3 3 is 6. 3 4 is 7. 3 8 is 8. 3 6 is 9. Right? Now 6 4 is 10. Yes, 10 is divisible by 5. So we're looking for this. 4 5 is 9. 4 4 is 8. 4 3 is 7. 4 2 is 6. 4 1 is 5. Yes, we're looking for this. Now 5 1 is 6. No. 5 2 is 7. 5 3 is 8. 5 4 is 9. 5 5 is 10. Yes. 5 6 is 11. 6 6 is 12. 6 5 is 11. 6 4 is 10. Yes, we're looking for this. 6 3 is 9. 6 2 is 8. 6 1 is 7. So our marked out places are where you have faces of which their sum is divisible by 5. So how many are there? We have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So we have 7 of them. Okay? We have our B. We have total score divisible by 5 is 7 in number. All over. Our sample space is 36. Okay? So now this is how important our dice table is. Now believe me, without this dice table, you will not be able to solve these questions. Okay? So you use a dice table whenever you have 2 dice being thrown twice, or where you have a dice. Where you have, 2 dice being thrown simultaneously, or where you have a dice being thrown 2 times.